Good afternoon. I'm Hugh Dyer, an Associate Director in RSK's Geosciences business. Welcome to the August edition of our 2024 series of Down to Earth webinars. These talks cover a broad range of subjects through the year and are available afterwards on our YouTube channel alongside previous talks. Our talk today will be given by Brian Harding, who heads up our surveying team. Brian will give us a look at how we can get the best out of topographical and other surveys and the potential pitfalls of poor quality or underspecified surveys. But firstly, a brief note on housekeeping during the talk. All attendees' microphones are automatically muted throughout the webinar. During the presentation, you can post questions online and there'll be a Q&A session at the end of the presentation. We'll answer as many questions as possible. Those that can't be answered due to time constraints will be answered after the webinar. Shortly after the webinar, you'll receive a link to a short survey. If you could take a few minutes to provide feedback, please, so we can improve on our future webinars. Now, please let me introduce our speaker today. Brian Harding is an Associate Director within the Geoscience business. Brian is a member of the Chartered Institute of Civil Engineering Surveyors and is the above ground geospatial technical lead and team leader for the RSK Geospatial team. Brian has been in the surveying industry for over 2 decades, starting as a CAD technician in 2001 and moving into the field role in 2003. So I'll hand over to Brian now to give us an insight into specifying surveys and getting the information you need. Thank you, Brian.
Thank you very much, Hugh. I'll switch off my camera. Thank you, everyone. So, as Hugh said, I'm Brian Harding, member of Chartered Institute of Civil Engineering Surveyors. I've over 20 years of experience in the survey industry, working in the UK and overseas. As part of this talk, I have included 2 Slido questions. I've put the QR code on here, so if people can participate, it would be very much appreciated. So, procuring a geospatial survey. This talk is really based more around looking at topographical surveys. However, what's outlined in this presentation does include all geospatial surveys, whether that's measured building or monitoring. So where to start? When scoping a survey, a good place to start is with a familiar Venn diagram. So looking at the quality, the cost and the speed, and understanding where this work needs to sit. Once you understand that, it's much easier to scope the work correctly. So if price is the most important part, explain this to your geospatial provider. They will be able to make sure that they scope it accurately. If quality, by quality we generally mean accuracy, is of the highest importance. Again, stating that will help make sure that the work is correctly scoped. So the first question I will ask, and the question will come up when I change slides, is how do you currently procure a topographical survey? So I'll just give the audience 30 seconds. If people could click on and let me know how you currently go about procuring surveys, that would be very much appreciated. Okay, that's interesting to see. It's very similar to what we find As everyone saw, the results generally is, please can we have a price for a topographical survey at the below address. So when you think about it, this is a way of procuring a service with only 2 words, and that's topographical survey. I don't think any other or many other industries you would find that just 2 words would cover exactly what you need. So if you went to a builder and said, I would like an extension, they wouldn't be able to give you a fixed price cost for that, but it's something we do see very often in the survey industry. So when procuring geospatial services, it's very important to remember a few key points. First is important to understand that not all topographicals and other geospatial surveys are equal. What I mean by this is you can have 2 surveys completed by 2 different companies that look very similar. However, the amount of work and effort that went into those could greatly differ. Another point is technical jargon in proposals may be misunderstood by clients. A common one we see is plot scale of 1 to 200 or RICS relative band accuracy. Unfortunately, there is not much in the way of industry standards governing the UK above ground geospatial industry. Why do we need to worry about liability? If the client doesn't state what they want, it is on them. This is a statement that I had recently at a conference where we were talking about the need for a PAS, a public accessible standard, or a British standard for the UK above ground surveys. Finally, the UK Geospatial Commission has never done an investigation into the cost associated with poorly collected geospatial data. So what can go wrong? Excuse me. So example 1, one of our clients commissioned Company A to produce a topographical survey of their site. The drawing itself looked very, very detailed, had a lot of information. And we vetted this drawing quite closely prior to work starting, and on the face of it, it looked very good, in the same way that the TSA would vet their members' drawings. So everything looked extremely well. However, before we started work, we decided to do a control verification with inside this yellow area on the below sketch. What we found was that approximately the control was out by 30 to 85 mil. This was delta error between stations in horizontal plane. We found that the legend had a caveat that said it was accurate to 1 to 500 scale. We found evidence of 15 legs of open trellising. So that's control that doesn't have a QC or a close. We found that on 2 different drawings, the level datum for the site was stated differently. One stated that it was the GNSS value at a noted station, and the other one said that it was based on an OSGB benchmark on site. What does all this mean for our client? It means they are likely to need to commission a new topographical survey at some point, as the current one doesn't meet the accuracy requirements of the architects. It also means that all other historic geospatial surveys that have been completed on site, like PAS 128 and other 3D scanning, is likely to be sitting on the wrong datum or all on separate datums. So again, all this data at some point may need to be recaptured. Our example number 2, so one of our clients asked us to survey trial pit locations for a railway tunnel. We were told that the high accuracy control had been already established on the site, and we could use this for our works. When we come to plotting the control, if you look at the image on the right, you'll see that none of the control actually sat within the tunnel itself. So we raised this with the client, and they went back, and eventually it took us 4 to 5 months before we got final control coordinates. The work was done during weekend nighttime possession, so we know that it was very costly, and the control was completed more than 3 times before final coordinates were issued to the subcontractors. Example number 3, a topographical survey was completed of a large rural site in the south of England. A design of 9 detached homes was finally approved by planning. Construction started, it was around 2 to 3 years later than the original topo was completed. However, in this time, all boundary features were removed from the site and no permanent control or PGMs were left on site. The site manager instructed the engineer to set out from common features that were still on site against the engineer's professional opinion. What this meant that 4 of these buildings facades were built on neighbouring land, so highlighted on the right there. 4 facades were actually built on a parcel of land that wasn't owned by the client. I didn't find out the full history of this site. I don't know whether the client was managed to pay the ransom price for the land, or they had to demolish these buildings and have them rebuilt. But either way, we can assume it was a very costly exercise for the construction company. Some other examples that I can go into was multiple homes were constructed without the means to displace the surface water. The nearest culvert invert level was over 350 mil higher than the water outlet, so the water had nowhere to go on site and there was no feasible area or location that the water could be run off site. So water had to be pumped out monthly. I don't believe there was a financial viable option, so as far as I know, that water is still being pumped out on site. Many kilometres of pipeline on another project had been designed to survey data that was incorrect. This meant that multiple redesigns was required throughout the project, and this had huge impact on the programme. A large plant was constructed. Unfortunately, each area of the plant was on a separate was on multiple local coordinate grids, and as such, all connections had to be surveyed prior to design. So any prefab steel or pipework had to be designed on the fly, and again, this had a big impact on the programme. Multiple dwellings built to ground floor level before the site manager was made aware that the main drainage run invert level would not flow. So the building control would not sign off the drainage because the only way it was going to connect was to have less flow than building control would allow. Again, I'm not too sure what the outcome of this was, but it, again, would have been very costly for the construction industry. A high-rise building in Canary Wharf was due to be set out with a new floor layout. However, due to errors in the original measured building survey, the design didn't actually fit on the floor. The floor plan was out by about 300 mil once it had been stripped, and it didn't conform to minimum width for wheelchair access. So again, the floor plan had to be redesigned and set back out again at a later date. So why do clients accept the liability and unnecessary risk from survey data? If I could take the liability to answer this myself, I'd say it comes down to 3 points. One is a lack of client education in this area. RICS, CICES and the TSA are doing some client education pieces at the moment to try and make sure that clients are or at least aware of potential risks when not specifying what is required. Again, as I said before, there's a lack of an investigation to see what these associated costs are going to be. So without understanding what the cost of having survey data wrong, we don't know how important it is to get it right. And then the lack of a public accessible standard or a British standard covering the geospatial services. So I think these three points are the major reason why clients are put at unnecessary risk from survey data capture. So what can a client do to mitigate these risks? There are several ways of mitigating the risks. Some of the construction and design risks associated with or procuring a topographical or geospatial survey. First recommendation is to use an organisation with professionals affiliated with an industry body. So the industry bodies that govern the survey industry is the Royal Institute of Chartered Surveyors, Royal RICS, Chartered Institute of Civil Engineering Surveyors, and the Survey Association. So these above professional bodies oversee the industry, vetting companies and individuals to uphold professionalism and make sure members meet a certain level of education and experience. Seeking advice from members of these organisations will ensure a level of professionalism, and in the case of dissatisfaction, gives the client a body to go to get advice, and if necessary, contacts for expert witnesses. So an important step in mitigating the risk of procuring surveys is to make sure you detail exactly what is required. So a specification is vital as it provides clarity. Surveyor will fully understand what is expected and what is required to meet the client's needs. It will provide cost savings. It will ensure the work is priced based on the client's requirement, not what the tender manager thinks the client requires. Gives better comparisons, so the additional benefit is the client knowing that all proposals that come in of similar requirement, so there's no use comparing apples with oranges. It gives you a level of guarantee, so the specification will provide the client with a level of guarantee, which should ensure that the work can be relied upon with a greater level of confidence. And finally, protection. So the survey industry has several terms and caveats that may not be clear to the client who may have little or no geospatial surveying knowledge. Most common one that we see is legacy plot scale of 1 to 200. This is also known as band F accuracy, which is fairly low accuracy rating. Unfortunately, this may not be fully understood by the client when reading the proposal. So we're going to look into this a little bit more, sort of try and explain what 1 to 200 may mean. So on page 13 of the RICS guidance document, the third edition, which was effective from the end of 2014, RICS introduced a new band accuracy. This was to move away from legacy plot scales as we are now in the digital age. One we'll look at in more detail is band F, plot scale of 1 to 200. So the first column shows the new band accuracy. The second one is Sigma 1 plan accuracy, which covers 68% of surveyed points on site. Second section is Sigma 2 plan accuracy, which covers 17% of the points surveyed. Then we have our vertical accuracy of hard surfaces. We have our vertical accuracy of soft landscaping. We have example survey types. So in this example, we have low accuracy measured building and topographical surveys. We have the legacy plot scale, and we have minimum feature size, which is shown at true scale. So having a look at page 12 of the RICS guide, under section 2.2, we'll see that there's a formula that shows you how accurate survey information will be under each band of accuracy. So I would like to draw everyone's attention to this section here. This is the band accuracy, but that's from the local control. So if your control accuracy is low, this will add on, be accumulative to the error within the actual band accuracy. So if we have a look at this on a typical site, if we completed the work to 1 to 200 band F to RICS guidance and increasing what we find is an increasing number of survey companies choose to complete surveys using one-person crews. It's a cost-saving exercise, but does reduce the control accuracy. So what we find when traversing with a pole and prism, we expect an accuracy of somewhere between 1 in 5,000 and 1 in 15. This can change, it's subject to change, but this is kind of average range, as it were. So if we use the average scenario, we're looking at around 100 parts per million, or 1 in 10,000 for control completed one person using a pole and 360 prism. If we work into band F, sigma 1, so again 68% of surveyed points, we'd find that those would be equal to about 71 mil of error between 2 points on site. If it was to fall within the 17% of sigma 2 surveyed points, then we'd be looking at about 141 mil of error. So these examples do exclude the traverse error, which we'll show in the next slide. So what does it mean in real-term accuracy on a site like this? So we have this building on site. If you measure it with a steel ruler, a calibrated steel ruler, you would find that that building is 65 meters, 0.00 in length. On a 1 to 200 topo survey, it could be shown to be incorrect by up to 94 mil, or even as much as 164 mil, if it falls within the 17%, so the sigma 2. So in this example, this 65 meter building could be shown on survey at 64.836, or as much as 65.164, and still meet sigma 2, still meet band F accuracy. We can apply that same formula to the boundary extents on the yellow line on the picture. We could say that this 85.5 meter boundary or site width could be shown as 85.336 or 85.664. So that's where the range of error will still be compliant to band F or 1 to 200. So if we look at this site again, but now we'll look at it with a simple specification that I've written. So specification would read as, we would like a topographical survey completed on the site below with at least 4 number PGMs installed with a minimum 5-year lifespan. Control is to be installed to a minimum accuracy of 1 in 20,000 with detail collected to band D accuracy. Deliverables should include a control report and 2D and 3D CAD drawings. So not a huge amount of work, but a very small written specification here. And we'd see that our band D sigma 1 of surveyed points would read like this. So we would have 14 mil of allowable accuracy or inaccuracy. Again, back to the example before, if we're looking at the building, so we're adding on the control inaccuracy, that could be out by up to 25.5 mil. And then for sigma 2, using the same formula, we'd be looking at 28 mil of error, or if you include the control error in there as well, up to 40 mil of plan error. So by stating the control requirement and the detail band, we have managed to bring our error down significantly. So a rough comparison of these options. So a topographical survey completed without specification and one with a very simple one. We have control left on site, which would generally be without specification TBMs. They have a lifespan of 1 to 2 years. Control accuracy, we can assume would be around 1 in 10,000. The error between adjacent control could be as much as plus or minus 10 mil with 360 prism. Band accuracy, sigma 1, so 71 mil error from the nearest control station. Sigma 2 would be 141 mil max error from the nearest control station. You wouldn't receive a control report, so you'd have no QC confirmation on site. And the approximate cost for a site like this may be around £1,500, and that would be completed by a 1-person team. So if we look at the other option where we provide a specification, There's a slight error here. It's actually, you would have PGMs installed on site. Their lifespan would be around 5 years, according to the RICS guide. Control accuracy would be 1 to 20,000. Error between adjacent control would likely be plus or minus 2 mil. Band accuracy sigma 1. D would be 14 mil max error from nearest control. Sigma 2 would be 28 mil. Control report would be provided, which gives quality control over the data and can be reviewed. And the approximate cost for this survey would be 2,300. So there's two comparisons and how the price changes depending on your needs. It's also worth noting that RICS recommend that clients wanting 95% confidence in the required band accuracy should request one band higher. For example, if you wanted to achieve band D sigma 1 accuracy, you should request band C, and that would then give you 95% confidence in those points on site. So what we're really talking about is liability, and that's what this is what it comes down to. By having a specification, you are covering your liability on site, and the liability then falls to the survey provider. So where do you go to get a defined geospatial specification? So the 4 options that I've outlined here. You could employ a senior surveyor, preferably one that's a member of RICS or CICS, and they'd be able to write you a bespoke specification for each and every site. Option 2 would be to commission a senior surveyor to write you a generalized specification. They could leave tick boxes in there and put in some sort of minimum requirements, but again, make it much easier for companies to procure topographical surveys with a level of confidence. You could use the RICS professional guidance document. So the RICS guide is available online, and it's just a simple tick box exercise to go through, state what you want, but you do have to have a level of knowledge to understand what you need, because there are requests that need to be covered, such as control accuracies. Or you can talk to a geospatial specialist. So many service providers will be happy to give advice on a call. And if requested, we are quite happy to provide detailed specifications within our proposals, and these can be used to get additional proposals so you can compare costs. So the option 3 of using the RICS professional guidance document, I've added a QR code so people can easily bring up this document. The RICS professional guidance is a great tool for clients to outline what they require. However, the document is just a tool, so you have to actually put information into that to get what you need to turn it into a specification. If it's left blank, then it gives you very little liability protection, and it doesn't tell the client anything, doesn't tell the service provider anything that is required on site. Despite the document containing 51 pages, I would say that 7 of these are 100% necessary on most projects to cover what is required. Page 6 is the survey control accuracies. Page 13 covers the band accuracies. Page 15 is survey control network. Page 16 is survey control accuracy and output. Page 17 is PGM information. And then pages 19, 27, 31, 33, and 35 are site-specific services. And then finally, page 37 is the deliverables. Option 4 is to talk to us. So please feel free to contact us. More than happy to talk you through any options for your requirements and look at the right solution for your needs. Our contact details will be shared at the end of this presentation. Another important section in the scope is the red line boundary, or the area of survey works. To reduce the costs and to assure the right information is gathered, it's important to clearly define the survey area, outline any restrictions, we often get a survey outline that is extended beyond the client's required area. Example below on the left would be half the cost of the survey on the right. The reason is that these areas here may be priced and surveyed, and these areas, although are not proportionally a lot of the area, are significant in accuracy, significant in detail. So there's a lot of work in these areas to collect that information. So if it's not needed, having that defined boundary will really make a big difference in the final cost. So just to recap on risk mitigation when procuring surveys, make sure the company providing the service has members of an outline professional organisation, so CICS, RICS and the TSA. Include a clearly defined survey area and any access restrictions, so just covering whether you need the adjacent road, the access road, adjacent buildings, and then a detailed specification, so covering control requirements, the accuracies and the deliverables. So our final Slido question is, do you think this talk may have changed how you procure geospatial surveys in the future? Again, there's a QR code that will take you to this Slido. Switch to the next one. That looks very good from first review of this poll. So, excuse me, organisations and contact information. So I've added again some QR codes here of the CIS, RICS, TSA, and our website. I've also added our contact information. So if you'd like to contact us for a proposal or for any advice, you can email us at RSK topographical inquiries at rsk.co.uk. Feel free to contact me on LinkedIn, which is Brian Harding, RSK Geo. Thank you all for your time, and we'll go over to Q for Q&A.
Right, thank you, Brian. Yeah, that was really interesting. I know we've spoken about a few of these issues on sites before, but it was really interesting to hear a lot more of the background on that. We've got a few questions that have come in. So please, if you do have questions for Brian, submit them quickly and we can add them to our list. So firstly, where are my questions? What do you think is the most important information to be present in a specification for a topo survey?
I would say that there are two things that are very important. One is the control accuracy. As I explained before, if you don't specify the control accuracy, your band accuracy kind of gets blown out by the inaccuracy in the control. So specifying what you would like from the control is very important. And then the band accuracy, so actually stating which accuracy you're hoping to work to, or to have this data accurate to, and by that you'll be able to write a methodology, and generally the lower the accuracy, the more economical the survey. So having it right is a very good way to get a very economical cost for what you need.
Okay, I've got a question here on survey errors. So we had a few, you talked a bit about survey errors and then control network errors. And then you spoke about the control network through the tunnel. So what should the control, is there a big difference between the control network error, as in between control points, and then the survey errors? And should these be different?
So generally, if there is a problem or a gross error with a survey, it's generally going to fall to the control. The control is generally your way of QCing your data. They are separate, so your control error will just amplify your detail error. So they propagate on each other. So the control error will mean that the detail error increases with the control. I hope that covers what you meant there.
Yeah, I think it was. So is it more accurate between the control points, or does the guidance then set out it's more accurate between control points than your accuracy you're getting for the wider survey?
Yeah, so the control on the site is going to be your highest order accuracy, and because it's a defined point, you can get the center of that control within a couple of mil. So you know where that point is and you can go back there. So setting out engineers will use that control to plot, design, and put it on the ground so the construction crew can actually start to build.
So I suppose the follow-on question from that is, why is it important to have the control network or the control report? And does this relate then to other surveys that are done further down the line?
A control report isn't always necessary. I think it's a very smart thing to ask for because you will have a level of confidence in the control. It can be reviewed. I suppose like any work, if you have a report to sit alongside it, you will then have a level of confidence in the work that was done. So yeah, a control report isn't that expensive in comparison to the survey, and it will give you a level of confidence that the work has been completed correctly and to the specification. So it's a good thing to ask for, to keep on record. So if any issue arises, that you actually can go back to that and say, right, I'll get the work vetted. Was it done correctly? And again, it's trying to make sure that the client is putting the liability for the accuracy of the survey for what has been produced on the survey company. It seems that really the construction company or the designers to some degree take most of the liability on survey data being inaccurate within the UK, certainly. So by having a specification, having a control report, you are then kind of covering yourself for that liability later down the line.
Okay. Do the RSK bands apply to vertical as well as plan accuracy?
It's a good question. I asked the president of RSK recently because it wasn't very clearly stated, but it does apply to the vertical accuracy as well. So the vertical accuracy is generally very similar to Sigma 1 accuracy for hard detail. So you can generally apply the same correction or the same error value to the vertical as to the X and Y on the Sigma 1.
Okay. You mentioned using multiple local grids across the site. So what's the risk of using multiple local grids? And what would be the impact then on the survey?
Again, it always depends on the site and on what's going to happen on that site. Generally, you want a source of truth. If you have one source of truth, everything fixes to that. So rather than having to keep paying for surveys to be redone, they all are connected to the one source of truth, which is generally going to be your control network. all data will time perfectly to it. So if you have one control network for the whole site and everything fits to that, you can expand the survey, you can update small areas of the survey, and it will always drop in exactly the right place. So you don't have the chance where two sets of data are sitting on two different grids. They might be minor error, but then when you generally start to work on them, so the setting out engineers will often put in new control, and it's a propagation of error. So you start with a smaller error and you're allowing that to keep increasing. Having a very good control network, having one coordinate grid for your site, you keep everything on one source of truth.
So say if you had a large site and you were just surveying a small corner for now, would you advocate then doing a control network across the larger site in order to future-proof that, so then as you add more survey information on, you have that control grid that spans the furthest extents?
Ideally, yes, but obviously there's budget constraints on any work. So the ideal is always to work from the whole to the part. So you work from the whole site and you work in. If you do that, you'll have better survey data and it will last longer. Everything can kind of be built around the control network, but obviously there's always a cost restraint, and sometimes, you know, if you only need a very small area of survey, you're not going to pay for the whole site to be with a control network. But in an ideal world, any big organization, airports, large gas and oil plants, they will generally have a control network that will sit across the whole site, and any subcontractor they get in will then tie into that. They'll also provide a control report, and all the control will be ordered. So in surveying, you have a control hierarchy, primary, secondary, and tertiary. So if this is managed well, everything stays on that single source of truth, and the error doesn't get increased beyond its limitations of that site.
Right, excellent. I'm conscious of time, so I think we'll stop the questions there, and any further questions we'll answer, Brian can answer after this and get back to you. So thank you ever so much to Brian for his presentation today. Our next Down to Earth talk will be on Tuesday, the 10th of September, and that'll be the second in our series focusing on silt and surface water management in development sites. So please remember to complete the feedback following the presentation, and our email about our next Down to Earth talk will be going out shortly. So thank you for attending today, and we'll see you again in September.